Welcome back to Prep Forge. In our last deep dive we covered Apache Kafka. Today we tackle the other messaging technology interviewers love to ask about, RabbitMQ. And here is the thing most candidates get wrong. They treat RabbitMQ and Kafka as the same tool. They are not. By the end of this video you will understand exactly how RabbitMQ works, and exactly when to reach for it instead of Kafka. We will cover the broker model, exchanges and routing, acknowledgements and delivery guarantees, durability, fair dispatch, dead letter queues, and finally when you should use RabbitMQ, and when you should not. Let's get started. Before any of the mechanics, let's answer why message brokers exist at all. Imagine service A calls service B directly. A has to wait for B to respond. If B is slow, A is slow. If B is down, A fails. This is tight coupling, and it does not scale. A message broker breaks that chain. Service A drops a message with the broker and moves on immediately. Service B picks it up whenever it is ready. You gain three things from this. Decoupling, because A and B never talk directly. Load leveling, because a traffic spike fills a queue instead of crashing B. And resilience, because B can be down for a while without a single message being lost. Concept number 1, the core model. RabbitMQ implements a protocol called AMQP. And there is one idea here that trips up almost every candidate. In RabbitMQ, producers never publish directly to a queue. They publish to something called an exchange, and the exchange decides where the message goes. If you remember only one sentence from this video, make it that one. Let's walk the building blocks. First, there is a connection, a single TCP connection to the broker that you keep open because it is expensive to create. Inside that connection you open channels. A channel is a lightweight virtual connection, and all the real work, publishing and consuming, happens on a channel. Then comes the flow itself. A producer sends a message to an exchange. The exchange uses a rule called a binding to decide which queue or queues the message belongs in. The queue is the mailbox, and it is the only component that actually stores messages. Finally, a consumer pulls messages off the queue and does the work. Producer, exchange, binding, queue, consumer. That is the whole pipeline. Concept number 2, exchange types. This is where RabbitMQ really earns its reputation, because its routing is far richer than Kafka's. The exchange type controls how a message is routed, and there are 4 of them. Interviewers will expect you to name all 4 and give a use case for each. Here are the 4 types. A direct exchange routes on an exact routing key match. A message keyed payment goes only to the queue bound with payment. Use it for straightforward point-to-point work. A fan-out exchange ignores the key completely and copies the message to every queue bound to it. This is broadcast, or publish-subscribe. Think order placed, going at once to the email service, the analytics service, and the warehouse service. A topic exchange does pattern matching on dotted routing keys, where a star matches exactly one word and a hash matches 0 or more. So a pattern like order.star.Europe matches order.created.Europe. Use it when routing depends on several attributes. And finally, a headers exchange routes on message header attributes instead of the key. It is powerful but rarely used. Remember the practical trio. Direct for targeted, fan-out for broadcast, topic for patterns. Concept number 3, acknowledgements. This is the single most important reliability idea in RabbitMQ, and it is the one interviewers dig into hardest. So let's be precise about it. Here is the life cycle. When a consumer receives a message, RabbitMQ marks it as unacknowledged, meaning delivered but not yet confirmed. The consumer does the work, and only then sends an acknowledgement, basic.ac. And only at that moment does RabbitMQ delete the message. Now here is the magic. If the consumer crashes before sending that acknowledgement, RabbitMQ assumes the work was never done, puts the message back on the queue, and redelivers it to another consumer. Nothing is lost. The setting that enables all of this is AutoAC equals false, which means you, the consumer, take responsibility for acknowledging after the work succeeds. Turn AutoAC on, and a crash mid-processing silently loses the message. Concept number 4, delivery guarantees, and this is the trap question. An interviewer will ask, does RabbitMQ give you exactly once delivery? And the honest, correct answer is no. With manual acknowledgements, RabbitMQ gives you at least once delivery. A message is never lost, but under failure it can be delivered more than once. Picture this. The consumer finishes the work, but crashes just before the acknowledgement reaches the broker. RabbitMQ never heard the ACK, so it redelivers, and now the work runs twice. The alternative, at most once with AutoAC on, is faster but loses messages on a crash. Exactly once, the holy grail, is not something RabbitMQ provides. So how do you handle it? You make your consumers idempotent. That means you attach a unique message ID, and you check whether you have already processed that ID before acting. If you have, you skip it. Reprocessing becomes a harmless no operation. The interview soundbite is this. RabbitMQ gives at least once, and I make it effectively once with idempotency. Concept number 5, durability versus persistence. These two words sound the same and get mixed up constantly, but they are different settings, and you need both to survive a broker restart. Queue durability means the definition of the queue survives a restart of the broker. Message persistence, delivery mode 2, means the message itself is written to disk. Here is the gotcha that catches people. A persistent message inside a non-durable queue still dies on restart, because when the queue itself disappears, the messages in it go with it. So for work that must never be lost, you set both durable queue and persistent messages. One without the other is a false sense of safety. Concept number 6, fair dispatch, controlled by a setting called prefetch. By default, RabbitMQ hands out messages in simple round-robin order, one to each consumer in turn. And that can go badly wrong. Imagine two workers. One gets a run of heavy, slow messages, the other gets light, fast ones. With plain round-robin, the slow worker piles up a backlog while the fast worker sits idle. The fix is a setting called prefetch, set through basic.qos. When you set prefetch to 1, you tell RabbitMQ, do not give a worker a new message until it has acknowledged the current one. Now work flows to whoever is actually free. You are balancing by real capacity, not by a naive count. This one setting is the difference between an evenly loaded pool of workers and a jammed one. Concept number 7, the safety nets. Two mechanisms here that separate a toy setup from a production one. Dead letter queues, and publisher confirms. First, dead letter queues. When a message is rejected, or expires because of a time to live, or overflows a full queue, you do not want it to vanish, and you do not want it looping forever poisoning your consumer. Instead you route it to a dead letter exchange, which is a quarantine area you can inspect and replay later. Second, publisher confirms. Everything we have said about acknowledgements protects the consumer side. Publisher confirms protect the send side. The broker sends the producer a confirmation that it has safely taken ownership of the message. Without confirms, a broker crash the instant after you publish loses the message silently, and the producer never knows. Turn confirms on for anything that matters. Concept number 8, let's make it concrete. In practice, most teams use RabbitMQ through Spring, and it hides a lot of the plumbing. But the semantics underneath are exactly what we just described. In Spring, you declare your exchange, a durable queue, and the binding between them as beans, once. To send, you call RabbitTemplate.convert and send, passing the exchange, the routing key, and the body. To consume, you simply annotate a method with RabbitListener, naming the queue. Here is the elegant part. That listener acknowledges automatically when your method returns normally, and it rejects the message when your method throws an exception. So the manual acknowledgement dance we described earlier is handled for you. But, and this is the interview line, the semantics are identical underneath. Spring is doing manual ACK, at least once, on your behalf, which is exactly why you still write your handler to be idempotent. Concept number 9, the question your whole interview has been building toward. When do you use RabbitMQ, and when do you use Kafka instead? Get this right and you sound senior. Get it wrong and it undoes everything else. Here is the one distinction that decides it. RabbitMQ is a queue. Once a message is acknowledged, it is gone. You cannot replay history. Kafka is a log. Messages are retained, and many independent consumers can reread the same stream at their own pace. So reach for RabbitMQ when you need rich routing, task and work distribution, request-reply style messaging, or per message priority. Reach for Kafka when you need event streaming, the ability to replay past events, analytics, or many independent consumers reading the same firehose. Confusing the two is the classic mistake. Teams pick the wrong tool and then fight it for months. If you need to replay a stream of past events, that is Kafka, not RabbitMQ. Say that in an interview and you are done. And that is RabbitMQ, end-to-end. Producers publish to exchanges, exchanges route by binding, queues store, and consumers acknowledge. At least once delivery, made effectively once with idempotency. Durable queues plus persistent messages. Prefetch for fair dispatch, dead letter queues for the failures, and the queue versus log distinction that tells you when to choose it over Kafka. If you can explain those clearly, you can handle any RabbitMQ interview question with confidence. To practice these out loud with mock interviews and spaced repetition, head to prepforge.net. If this helped, subscribe, because Amazon SQS is next. Thanks for watching, and good luck in your interview.